This is Euclid Book 9, proposition number 17. Now, do you know how we've been going as A is to B, as C is to D? Where we said as 1 is to 2 is to 4, because 2/4 is really 1/2. Okay. In this particular proof, we are going to prove that C could be such a number that there won't be able to be placed a D underneath. In other words, you'll have as A is to B, as C is to what? See what I mean? There won't be a D. You say, go, how could there not be a D? You're going to find out in just a second. Okay, here's the diagram. Okay. And now, let's get into the proof. If there be as many numbers as we please in continued proportion, and the extremes of them be prime to one another, the last will not be to any other number as the first is to the second. That's why we're saying there will not be a D. As A is to B, so as C is to D, but this time there will be a D. And here's the reason why. For let there be as many numbers as we please, A, B, C, and D in continued proportion. Okay. As 1 is to 2, so is 2 is to 4. That's a continued proportion. Okay. And let the extremes of them, A and D, be prime to one another. Now, obviously, if you have 1 is to 2 as 2 is to 4, then A and D are not prime to each other. Okay? I say that D is not to any other number as A is to B. For if possible, as A is to B, so let D be to E. In other words, here we go. As A is to B, so will D be to E. Okay. Therefore, alternately, as A is to D, so will B be to E. And this is by Euclid Book 7, proposition number 13. So now we're saying, as A is to D, so will B be to E. Okay. Here we go. But A and D are prime. Now remember, they're prime to each other. They're not prime numbers, but they're prime to each other. Primes are also least, by Euclid Book 7, proposition number 21. And the least numbers measure those which have the same ratio, the same number of times the antecedent to the antecedent, and the consequent to the consequent, which is by Euclid Book 7, proposition number 20. Therefore, A measures B. Okay? That means that this here will measure this here. And as A is to B, so will B be to C. So now we're saying as A is to B, so as B is to C. Okay. Therefore, B also measures C, so that A also measures C. And since as B is to C, so as C is to D, B measures C, therefore C also measures D. Okay, let's start back there. Here. As B is to C, so as C is to D. As B is to C, so as C is to D. And we also said, and since B measures C, therefore C also measures D. As B measures C, so will C measure D. That's what we're saying. But A measured C, so that A also measures D. So we already said that A measures C. Now we're going to say that A also measures D. Are we starting to see a problem here? Hang on to your horses. But A also measures itself. Therefore, A measures both A and D, which are prime to one another, which is impossible. Therefore, D will not be to any other number as A is to B. And that is the whole proof. I will tell you more in a future video. Stay tuned.